I'm Dr. Brian Storz, the Licking River Basin Coordinator with Kentucky Division of Water. And if you live near a lot of paved surfaces like roads or parking lots, you're probably pretty familiar with the issues of stormwater runoff, which is why our cities and towns have stormwater basins to help control and conduct the flow of stormwater runoff. But there are many ways to improve the effectiveness of a conventional stormwater basin. And today we're here to talk to you about stormwater basin retrofits, or more specifically, how to turn your conventional stormwater basin into an improved tool at regulating not only the quantity of stormwater, but the quality of stormwater before it hits your local streams. To discuss retrofitted improvements that can be made to a conventional stormwater basin, let's turn to Nicole Clemens.
Hi, I'm Nicole Clemens with the Bank Lake Watershed Council here in Northern Kentucky. Here we are today at a conventional stormwater detention basin, and this particular basin is in a residential area with about 18 acres that drains to this point right here. These basins were installed for flood control purposes, but not for things like water quality or erosion control. The flows come into this basin and then exit through this pipe here. What we found is that the small and medium-sized storms flow through this pipe and into the local creek without being retained or detained at all. It's not until the water gets much deeper in those really large storms where the water starts getting held back. What the research shows us is the water is leaving this basin with just too much velocity, too much energy, which is causing the downstream creek erosion. So the solution is fairly simple. We need smaller pipes. We need to shrink down the size of this opening so that it starts holding back those small and medium-sized storms, which is causing all the downstream erosion. Here we are at a retrofitted detention basin, and as you can see, these retrofits are super simple. All we did here was bolt a steel plate to the structure, and what that does is that shrinks down the size of that outflow pipe. When we design these, we make sure that they meet the relevant engineering standards, so the basin will still drain in an appropriate amount of time, and we're not going to overtop out the overflow control structure, which is located up this way. And we do the analysis of these to make sure that there is sufficient capacity within these basins to hold this excess water. Sometimes we do need to make modifications to the overflow control structure, like cutting windows into the concrete or plating those as well. But again, those are also super simple retrofits. Here you can see that we modified this overflow control structure with a window cut into the lower part of the structure. Again, a super simple retrofit, but what this does is this maintains the flood capacity within the basin. In other basins, we can use plating to gain even more capacity within the basin.
But how much reduction of stormwater basin outflow is needed to reduce erosion while still maintaining the efficiency of the stormwater discharge? For that, we need to understand the concept of Q critical with Bob Hawley.
Hi, my name is Bob Hawley. I'm the principal scientist at Sustainable Streams. Today I'm going to be talking about the concept of the critical discharge, or we call it Q critical for short. So the critical discharge is defined as the flow that actually moves the rocks on the stream bed, okay? So you take a rock like this and you get a flow that's big enough, the flow will pick it up out of the stream bed and move it downstream. Now, many of the particles in this stream have been moved really recently because you don't see any moss on this rock, and when I flip it over, you don't see any insects on this rock, right? So a lot of the particles in the stream have been moved pretty frequently. Now, if I pick up a bigger rock, that's a little bit harder to pick up. You see there's lots of moss on this rock. There's even some stream insects that live on the bottom of this rock. Not many, but some. So that means that this rock's been here a little bit longer than that other rock. So this rock's a little bit heavier and it stayed put for a little bit longer. So it's a little bit closer to a more natural erosion rate than the rock that I just showed you that didn't have algae on it. Now we're at a stream today that is kind of on the tipping point of having too much erosion. And you can sort of tell by a lot of these rocks don't have moss like that, and the stream banks are exhibiting lots of erosion. You can see in the background here, lots of exposed roots and bank erosion. With the knowledge of the critical discharge, that enables a stormwater manager to retrofit their existing stormwater basins to hold back water in a way that doesn't exceed that critical discharge, keeping that water nice and low and mellow, not causing those particles to erode downstream. The magic rate of erosion in many Kentucky streams is mobilizing those particles from about twice a year to once every other year. And the neat thing about that is the native insects that live in Kentucky streams tend to have life cycles that also align with that. You know, it takes them 6 months or 2 years to complete their life cycles on average. Now, those insects are a really important source of food for the fish that live in Kentucky streams. And so you can see where critical discharge and particle erosion is all tied to a healthy ecosystem.
I hope you found this segment helpful and informational for retrofitting your conventional stormwater basin or for planning the design of a new stormwater basin. For questions or more information, contact your Kentucky Division of Water.